In this video, we will do two things. First, I will type a program for the MaxHeapify function that was discussed in the previous video. You can see that, you must see that first. And the second thing is the homework that I had given in the past video. That homework will be discussed and will be seen according to the output of this program, so that we can verify that this program which I am going to type is running well or not. So I start. Here I type the header file. This stands in every program, and since I here go for the MaxHeapify function, so you must know that in that function I had discussed about a node and its right child as well as left child. So I have to take two more functions in addition to this MaxHeapify function. So I first type the function MaxHeapify, and in this there will be passed three arguments: one for the array name, second for the index which is to be heapified, which is to be MaxHeapified, and the last one, the last int, stands for the size of the array. Now I take two more function named left child, and in this only one argument will be passed, so a single int there, and accordingly the second will be the right child, and here as well one argument will be passed, and thereafter our main function begins. And for that I type here int main, and here a general thing is written to take the size and to take the elements of the array, and so I directly paste here something. You can check this part of the main function stands for the size and the elements scanning, and here one more variable is the index. This index stands for the MaxHeapify function. In the MaxHeapify function we work from a particular index. We start from a particular index, and that index is named here itself by itself, that is index. Now I go for the MaxHeapify function, so I call MaxHeapify function, and I pass three arguments. A is the array name, and this is the index to be heapified, and the third one is the variable for the size of the array. And in the end, in every program's main function return Now since I have called the MaxHeapify function, obviously I have to define it. So here I define function name is MaxHeapify, and in this we pass array name. You know, array name is the address of its first element. So here a with square bracket, second will be int, I take I for the index, and third the same size, and the variable is also the same n. And thereafter I call inside this MaxHeapify function, I call L, and this L stands for the left child, and according to our plan I have to pass one argument, only one argument, and thereafter I take one more variable r for the right child, and inside this I pass small r, sorry, the same index I, because we have to start from a particular index, and here to end the C statement I have used semicolon, and thereafter since I have called two functions, left child, right child, so I have to define these two functions. I define here, and these two functions are of return type, so here will be int, and here will be the first call is left child, so I type the function name left child, and here I take the same, that is int I, and here since this function is of return type, so I type here return 2 into I plus 1. You know, this is the formula for the index of the left child. Okay, this function is complete, this function definition is complete. Now we go for the right child, and you know the definition of the right child will be the similar, so I just copied and pasted here, but you know here will be the right, because we have done already for the left child, and here the formula for the right child is 2 into I plus 2. Okay, the definition, both the definitions are complete. Now here I declare one more variable named largest. This stands for the largest element. You know, for a particular moment we take a node, its left child and its right child. In MaxHeapify we compare these three values, and we choose the largest. For that we take if keyword and pass two condition inside this. First we compare with the left child, and you know that this index of any node must not be greater than n or equal to n. So I first here typed the first condition, L is less than n. Thereafter there will be the second condition, and the second condition is a l. Al means the value at the value of the left child, suppose it is greater than the value at the node then largest equals to this L, the index of the left child, and obviously there will be an else part, and this if the condition inside the if fails, then we take largest the index I will be stored in this largest. Now we have compared and got the largest among AI and AL. Now we have to compare with the right one. You know, a node may have a right child. For that, I use once again the keyword if, and this time I type the first condition accordingly. Right, the index of right child must be less than n, and the second condition, AR, the value of the right child, if this is greater than the A largest, then largest should be R. Okay, so we have chosen the index which relates to the largest value. Now it may happen that the largest value is not at the index, is not at the node with index I. It may be that the largest value is containing by the left child or by the right child. For that I use one more if keyword, and inside this I type a condition if largest is not equal to 1, not equal to I, only then we interchange. And to interchange, you know, I have to take one more variable. You may say it temp, and here I use that temp variable, and here AI, I store the value of AI in the temp, and thereafter this AI will store the value of A largest, and the last part of this interchange will be A largest should store the value of the temp, so here will be temp. Now this interchange is complete, and you know, whenever this interchange takes place, there should be a recursion, there must be a recursion, and you know, recursion means the function calls itself. The function is MaxHeapify, so the same function we have to write here, MaxHeapify. And since this MaxHeapify contains 3 arguments, so accordingly I have to pass 3 arguments here. And here the second thing will be, you know, in the past video I have shown that the movement the movement happens in the direction of exchange. Since the index I and the index with the largest value takes place. So here the index will be the largest, and first and the third argument is all first and the third argument, both arguments are always same, so here will be n. And now I think our program is complete. So now I should run this program. Okay, I run this program. Let us see what happens. Okay, as usual it says to save the program. Okay, I save under the name MaxHeapify. I save the program. It says largest was not declared in this scope. Okay, here I must write largest, but by mistake I have typed here largest. R is not there, so I typed R now. Now I execute it again. Yes, execution is successful, but we have to see that our output is according to our desire or not. And since the written words on the screen are small, so I magnify this. Now you can see it says enter the size. So I take the same example, I take the same array that was in the previous video, and the size of that array was 8, so I place 8 here. And in the past video I had given a homework to the viewer. In that I had requested to find the MaxHeapify corresponding to the index 0. That is, for the root node you have to MaxHeapify that array. So I try to get the MaxHeapified heap using this program, and after that I will check whether it is true or not, taking a heap. So I take the same elements 12, 3, 5, 6, thereafter 0, minus 2, 17, and the last one was 53. Okay, it is not showing any output because in the main function I have not, here in the main function I have not used the printf function. So I use here printf function to show the output. The MaxHeapify array elements are okay. So to show the elements we use a for loop with printf function. So I just copy this thing and I paste here. There will be a little modification I show you, and here will be no ampersand, and here I will use printf function to show the output. Okay, now it is okay. Let us run the same data. Let us feed the same data inside this program. Size is 8. Elements are 12, 3, 5, thereafter 6, 0, minus 2, thereafter 17, and the last one is 53. And here as well, you see the elements are without a space. So once again I make a change in this printf function so that we may get the sorted, the max heapified array elements with a tab distance. For that I use here \t. Now see, you will see you will get the same elements, but this time with a distance. Here I place the size, same size 8, and now the same elements 12, 3, 5, 6, 0, minus 2, thereafter 17, thereafter 53. Now I press the enter key, and here you see the max heapified elements are, you see the same array elements in the same order, and this is because here I have not mentioned which index is to be max heapified. For that I again print a message to show the user enter the index to be max heapified. And for this obviously I have to scan that index, and for that %d, and to store that value at an address, here I have to type %index. Okay, now that index will be passed. Okay, now let us run this program. Enter the size. Here I place the same size 8. Array elements are 12, 3, 5, 6, 0, minus 2, thereafter 17, and the last element is 53. So you see 1, 2, 3, 4, 5, 6, 7, 8 elements, and I press the key enter, and now it is asking for the index to be max heapified. And you know, in the homework you were requested to max heapify the first element, and you know the index of the first element is 0, so I press 0 here, and thereafter I am going to press the key enter, and you see that we got the same elements 12, 3, 5, 6, 0, minus 2, 17, 53. Okay. Now I check whether it is true or not. For that, I will take you here is the output. I copy this output. Here is the output. This is the output. Output is the same. I copied. I here copy and going to paste. In one note. Yes, here you see the same work I have done earlier. You see here you see 12, first is 12, thereafter 3, 5, 6, 0, minus 2, 17 and 53. Okay, now I max heapify this 12. Here you see 12. According to program, I have to max heapify this 12. And if you see, it's right and left child with the node. In the MaxHeapify function, we compare these three elements, and you see that in the program the index for this is I, the variable I, and I is 0, and obviously I is the largest, so there is no need to interchange this value with either with left child or with right child. This means that the array itself is in max heapified form with the index 0. So our program is working well, but we can't say that our program is working well taking only one example. We should see taking some other example. So I take some other example, and in the past video I had explained the MaxHeapify thing, taking the same array that I took for this program, and this time as well I will take the same array, but the index will be different. This time I will take the index 1 and see what happens. Okay, I take the same size, the same array, that is 12, 3, 5, 6, 0, minus 2, 17, and the last one was 53. Now it says enter the index to be max heapified. As I said, I will take this time the index 1. Okay, I took 1, and thereafter I am pressing the key enter, and I entered. You see, this time the result is different. The output is different. So this time we must check whether our output is correct or not according to the definition of MaxHeapify. So again this time I check. I will here I go to copy this part, the output out. Yes, I took the output and I copied, and now I go on the one notepad. Here is the one notepad, and here I will verify the result. It is very small in size, so I have to copy once again. This is the older output. This is the new one. Here is the snipping tool to copy, and here I copy the output. This is the output. Here I copy and take the same thing to the notepad. Sorry, one note. Here is the one note. Here I paste. Okay. Now you see the output is on the screen, and you must remember that the array, the initial array that I fed into the program, I show that array. First was remember the array, the max heapified array on the screen. Okay, the array that I fed into the program was one notepad is not working, so I take a new page. Here I took the new page. It is still not working, so I eliminate and take from the starting point. Okay, here I type program, and here yes, now it is working. So the first element was 12, the second was 3, the third was 5, fourth was 6, fifth was 12, sixth was -2, seventh was 17, and the last one was 53. 53. And we have to MaxHeapify the element with index 1. So that index is here 1. So we compare. You must see that, you must see inside this, because the index of attraction is 1. So I take this heap, and here you see it is 3. So sorry, once I have written something wrong. Here is 0. Here is 0. Thereafter -2 here, and here is 17. Here was 17, and at the end it was 53. And we have to MaxHeapify the node with index 1. And that index is here. The index of 3 is 1. Okay, so we have to concentrate on this part. If you see this part, then in this part 6 is the largest element. You see, 6 is the largest element, so it will go inside the index 1. So I have to take 6 at this place, and 3 will come here. 3 will come here. Now we must observe that movement is along this direction. There is a movement, there is an interchange. Whenever an interchange takes place, then we have to move down. If there is no interchange, then there is no need to move down. Now again, the index largest, not the value. Keep in mind, the index largest is now with this node. So this time our concentration must be in this part. Look, in this part you see that there is no right child. Okay, no matter, we compare with the left child only, and you see that 53 is the largest, so it should come up and 3 must go down. So here will be 3, and here will be 53. Here will be 53. So our output must be 12. Here you see first is 12, and accordingly here you should note down. I say first is 12, thereafter 6, 5, 53, 0, minus 2, 17, and at the end 3. And if you check here, then you see the same. You see the same. First it is, here you see, first it is 12, thereafter 6, 5, 53, 0, minus 2, 17, and 3. You see the same. So the result, the program, the output of this program is being verified with the example shown on the OneNote page. I have also pasted the same thing here. If you check, first is 12, 12, 6, thereafter 5, thereafter 53, thereafter 0, minus 2, 17, and at the end it is 3. Okay, thanks.